All right, let's get into it. Today we're talking about system design, which is basically the hidden framework that runs our entire digital world.
You ever just stop and wonder about this? I mean, think about massive apps like Netflix, Uber, or WhatsApp. How on earth do they handle millions, sometimes billions of people all using them at the exact same moment? It kind of feels impossible, right? Like it has to be some kind of magic.
Well, here's the secret. It is absolutely not magic. It's system design. It's this deliberate, really thoughtful architecture that makes our digital lives even possible.
Okay, so that brings us to the big question. What is system design, really? The easiest way to think about it is like the master blueprint for any application. Now, the official definition is the process of defining a system structure, including its architecture, components, modules, interfaces, and how data flows between them to meet specific requirements. Whoa, okay, that's a lot of jargon. Let's make it simple. It's really just about figuring out how all the different pieces of a software puzzle are going to fit together and talk to each other to get a specific job done. Let's actually break that down into 4 core building blocks. First, you've got the architecture. That's the big picture, the grand plan. Then you have components and modules, which are kind of like individual workers, each one with a very specific job. The interfaces, that's just how those workers talk to each other. And finally, you have data flow, which is the actual information they're passing back and forth to get the work done.
But here's something you really need to get. System design is so much more than just drawing a bunch of boxes and arrows on a whiteboard. It goes way beyond the diagrams.
This quote just nails it. System design isn't just about drawing the diagrams. It is more about critically thinking and designing the high-level architecture. See, it's really about making those huge foundational decisions that are going to determine whether an app is a huge success or if it's going to fail under pressure. And those big decisions have to deal with 2 types of requirements. On one hand, you have functional requirements. This is just what the system does. Can you send a message? Can you book a ride? Simple. But then you have the non-functional requirements, and this is where great design really shines. It's not about what it does, but how well it does it. These non-functional requirements are so incredibly important, we can actually think of them as the 4 pillars. These are the essential qualities that hold up any great application. So first up, you've got scalability. Can the app handle a sudden flood of new users, say, during the Super Bowl, without even breaking a sweat? Second, reliability. What happens if one piece of the system breaks? Does the whole thing just crash and burn, or can it recover smoothly automatically? Third, performance. Is it fast? Is it responsive? Or does it just lag and make you want to throw your phone? And finally, maintainability. How easy is it for the developers to go in, fix bugs, add cool new features, and just improve the system over time? So let's tie this all together. Why does any of this even matter? Well, because getting the system design right, that is truly the foundation of a successful application.
And you got to remember, this is not a set it and forget it kind of thing. Behind every single app you use, there are teams constantly rethinking and refining the system design. They're always trying to solve new problems, whether it's scale or performance or efficiency. It's a never-ending cycle of improvement.
So what's the end goal here? It's to create a system that, as our source says, runs efficiently, handles massive loads, and automatically recovers from failures smoothly. In other words, a strong foundation leads to a system that just works, no matter what you throw at it.
Kind of makes you think, doesn't it? As you go about your day, using dozens of different apps and websites, just take a second to think about the incredible complexity that's running just underneath the surface. What's the invisible blueprint behind the technology you rely on every single day?